Hello, welcome back to the next part of this video. Okay, we are going to start by explaining what coefficient is all about in algebra. Let's take for example that you saw something like this. You saw something like 2x, you saw something like 6y, you saw something like 9x, you saw something like 5z, right? This is z, you know or let me put it like, yeah, you saw something like 3f and so on and so forth. If someone says, oh, okay, what is the coefficient of this particular algebra here? That is what? That is 2. What is the coefficient of y? That is 6. What of 9x? What is the coefficient of x here? That is 9. What is the coefficient of z here? That is 5. What is the coefficient of f here? That is 3. Right? So in essence, you're gonna say that you are going to say that the coefficient the coefficient is that number, the numerical value that is also always associated with the alphabetical letter in any algebraic expression, right? Okay, so if you are given something like this, 2x squared plus 3x, and they say what is the coefficient of x squared here? Because they mention x squared, what is associated with x squared as a numeric value is what is 2, right? Is 2. So I don't want you to get confused. So the coefficient of x squared is 2. Then coefficient of x here is what? Is 3. Coefficient of 2x squared. Coefficient of x squared here is what? Is 2. Do you understand now? Here is 2. Here is what? 3. So in essence, you are going to say that coefficient is what? Is the number or numeric value that is always associated with alphabetical letter in any algebraic expression. Okay, let's quickly go to the next part. The next part of this explanation is terms. When you hear terms in algebra, what is it all about? When you hear terms in algebra, what is it all about? Okay, so when you hear terms in algebra, what is all about is this. Let me assume that you have this, something like this, 2x plus 3, 2x plus 3, okay? The terms here means the fragment of that algebraic expression. Whenever you look at any algebraic expression that is mediated by either positive or negative sign, positive or negative sign, okay? You look at it is mediated by such, the fragment of such expression of that algebraic expression is what is called terms. So it means that in this particular algebraic expression, we have two terms here. What are the terms? What are the fragments? That's what they mean. The fragments here are what? 2x and what? And 3. The terms here are what? The terms here are 2x and what? And 3. 2x and 3. Do you understand? Okay, so these are the terms here. If you are given something like this, it's possible that you can have an algebraic expression whose terms there are up to 4 terms, 5 terms, 6 terms, 7 terms, and so on and so forth. Okay, and so on and so forth. When you have such, so it is possible, and the higher the number of terms, that is what determines the type of algebraic expression that is there. There are different types of algebraic expressions. There are monomials, there are binomials, there are trinomials. Okay, and so on and so forth. When you hear monomials are is an algebraic expression that whose term is just only one term that the algebraic expression has. Do you get now? When you see up to two terms, it means that such algebraic expression is binomial. Do you understand now? It's binomial, especially a situation whereby they are mediated by plus and what? And minus. Do you understand now? Okay. Then there is an important thing I want you to note here in these terms of a thing. There is an important thing I want you to note here in these terms of a thing. What is that thing that I want you to know? I want you to know that whenever you have unlike things, unlike terms, okay, unlike terms, they don't add each other. For example, you have 3x plus 2. There are two terms in this algebraic expression which are 3x and 2. But these 3x and 2 cannot add to each other, right? They cannot add to each other. 3x minus 2, these two terms here, they cannot subtract each other. Why? Because they are unlike terms. Do you understand? They cannot subtract each other because they are unlike terms. Okay? So whenever you are solving things like this, especially if it's something that involves algebraic equation, don't make it that whenever they ask you 3x plus 2, you go and write 5x. You are wrong. They cannot add together. They are not like terms. They cannot subtract together. They are not like terms. Do you get now? So whenever it comes to plus and minus, unlike terms cannot, rapport with each other. But this is a different case when you come to division and multiplication. When you come to division and multiplication, division and multiplication is a different case. Do you understand? When it comes to division and multiplication, it's a different case because in this situation, whether those things are like terms or unlike terms, they can divide together, they can multiply together. Okay, let's take for example to this illustration. When you see something like 3x times 2, 3x times 2, they can multiply together, notwithstanding that the terms here are not like terms. In fact, because they can multiply together, whenever multiplication sign or division sign is mediating such things, you don't call them terms because they can just multiply together. Whether the things there, the fragments there looks alike or not, whether both of them have the same letter or they don't have it, they are going to multiply together. So that's why whenever they are mediated by multiplication sign or division sign, you don't call those fragments there terms. Do you understand? Because they can easily multiply each other. 3x times 2, once they do so, you realize that the numeric value, we multiply this numeric value here, you get 6. You still have your x. Do you understand now? Okay, then if you have something like 3x times 2y, okay, in such a situation, you see that they don't have like letters. But notwithstanding the fact that they don't have like letters, the rule of the thumb here is that 3 must multiply 2 to give you 6. And when the different letters multiply together, you just bring them together. They're not just going to join and form one single letter, but you just bring them together. Just bring x and y together. Do you understand? Okay, so that is how the rule of the thumb is when it comes to multiplication and division. Just look at the things here, right? 3a times 5 will give you 15a. Do you understand? Okay, 2a times 3b will give you what? 6ab. Then 3a times 4a will give you what? 12a squared. The thing is that they multiply together. Okay, whether the alphabets they look alike or not, they don't care. In fact, I want you to pause this video as you are listening to this and take a look at this, read it, digest it, and understand it. See you in the next video.